I was told the last video was a little hard to read, so I'm going to try it again. Hopefully this one's better. What we've been working on so far is integrating x to a power. And we know that when we do that, we use something called the simple power rule, where we raise the degree 1. So we would raise the degree from 10 to 11, and then either divide by that new degree and add c, or some people like me prefer to multiply by 1 over that new degree. That's the same thing, but this is just a little easier for me to see. So rather divide by 11 or multiply by 1 over 11 and add c. So we were doing that with all sorts of degrees, like even if it was a square root or a square root in the denominator. We figured out what the exponent was on x, and then to integrate it, we added 1, and then we divided by that new exponent. So dividing by a half, we'd say 2. But what we're going to talk about today is what to do if what's inside the parentheses, or basically what is raised to the power, let's say at 5, isn't just x. It's a function of x. So it could be x squared minus 3, or 2x plus 7, or any number of functions of x. And there's an important thing we need to know is the dx that matches with the integral sign tells you what you're integrating with respect to. And if this thing isn't just x, then you can't just use the simple power rule. And so we're going to look at that on our worksheet. So the worksheet that I'm doing is on Canvas. You can get a hard copy of it on Canvas. But hopefully this will be a little more clear than the last video if you tried that. All right, so what we're doing now is talking about integrating when the thing that's raised to a power is not just x, it's a function of x. And when we do that, there's this other piece that we're going to need in order to be able to integrate. If this is our u that we're raising to a power, its derivative, so du dx, which would be 2x, has to be in the integral. It has to be there. If it's not in the integral, you're not going to be able to integrate. So like you see up here, our new general power rule is we're going to have a function to a power, and we're going to have the du dx, that's the derivative of that function, and then this dx that matches with our integral sign, telling us we're integrating with respect to x. What you can imagine is these two coming together to be du, so allowing us to integrate then with respect to u instead of x. And if we're integrating u to the n du, we're going to use the general power rule, but it looks a lot like the simple power rule. We're going to raise the degree and divide by the degree on u. But we can only do that if du dx is there to turn dx into du. So we always have to check and make sure it's there. And in all of these problems here, it'll be there. And we'll talk about when I get back when it won't be there. What do you do? All right, so we're going to do a little check and say, yes, du is there. These two can come together to be, du dx, the derivative of u is there. These two can come together to be du then, so we can differentiate with respect to u. So all we're going to do is take our old u, raise the degree to 3 instead of 2, and divide by 3, and add c. So most people say, well, where did that 2x go? Well, the 2x had to be there so that we could integrate with respect to du, with respect to u, so that we had our du, but it will never be in the answer. Like you can see up here, it's in the integral, it's not in the answer. If you check, you'll see why it was there. To check your answer, 3 times the third is 1. Then we drop the degree to 2, and we multiply on 2x because of the chain rule. So if it hadn't been there, then this answer that I said was right would be wrong. Without the 2x, I could never integrate this. So looking at the next one, the thing that has the power on it right now, that's how we're going to notice what u is. So u in this case would be this 5x plus 7, the one that has the power being done to it. The other way to notice, though, is when you take its derivative. That is the piece that we're looking for in the integral. Oops, sorry, you're not seeing this. So the derivative of 5x plus 7, which is 5, that's what has to be in the integral to be able to integrate, but it won't be in my answer because my answer is going to be raise the degree to 4 and divide by 4 and add c. And I know I'm right if I check it and I get back where I started. 4 times the fourth, drop the degree to 3, multiply on 5. It's exactly what I had in my integral. That's what I have in my answer when I check it. So here is my answer. All right, so for letter C, the thing with the power being applied is 3x squared minus x. Its derivative is 6x. And that means that 6x minus 1. Forgot to take the derivative there. Since that is right here in my integral, 6x minus 1, I can go ahead and integrate. I'm going to raise the degree on u to 7, divide by 7, and add c. The 6x minus 1 had to be in the integral. It is not in my answer. It'll show up again when I check. 7 times the 7th, drop the degree on u, multiply on 6x minus 1. So that's why the 6x minus 1 is there, because of the chain rule. We're working everything in reverse. So instead of adding on something when we take the derivative, it had to already be there when we do the integral. X cubed plus 4 is what the power is being done on, the power of a half. And so we're going to look to see if 3x squared is also in the integral, and it is. So because it is, we're just going to raise the degree on our u from 1/2 to 3/2, divide by 3/2, and add c. My check, 3/2 times 2/3 is 1. Drop the degree to 1/2, and the chain rule is giving me the 3x squared that had to be there. All right, so e looks like a fraction. It doesn't have to look like a fraction. It could look like negative 8x times 3 minus 4x squared to the negative 2. And so u is going to be this quantity that's raised to the power. And that means du dx is negative 8x, which is right there. So I have my du dx, I have my u to my power, I have my dx. I can integrate. And remember, what I'm integrating is a quantity called u to a power with its own differential, because the 8x and the dx, negative 8x and the dx become du. So again, that's why I'm just raising the degree to negative 1 on u, dividing by negative 1, and adding c. Check my answer. Negative 1 times negative 1 is 1. 3 minus 4x squared to the negative 2 times negative 8x. So that chain rule is telling me why the negative 8x is there. And once you learn to integrate like this, you will not forget the chain rule on the final when you're differentiating. Last one, this would be my u. It's raised to the second power. Its derivative is 3/2 x to the 1/2, which is right there. Since it's there, I can just go ahead and raise the degree on this u to 3, divide by 3, and add c. And then check my answer. 3 times a third is 1. 4 plus x to the 3/2 is now raised to 2 times 3/2 x to the 1/2, which is exactly what I started with. So I know I'm right. So hopefully that's a little clearer. You can practice that. Try your WebAssign, and I will see you tomorrow.